Okay, guys, we're ready for another math lesson. For today, you need a protractor and a ruler. If you do not have these two things readily available for you at home, I've linked some paper ones off of the internet that you can just go ahead and print, or you can go ahead and Google some for yourself. Um, Those are great for you to use, really, really helpful with this lesson. You'll also need your math notebook, a pencil, and a whiteboard or a piece of paper or something like that to participate. And here we go. Okay, so today our goal, our learning objective, is that we will review classifying triangles based on their attributes. This is something that you guys have learned how to do before, but we just want to review it with you since a big part of fifth grade is developing a hierarchy with different two-dimensional shapes. Okay, so what is an attribute? When I'm talking about an attribute, what am I talking about? An attribute. Now you're filling this in your notes, guys. You're filling this in your notes. By the way, your notes page should look like this. Classifying triangles. So you're filling in right here. We're starting our notes right away. An attribute is a characteristic, a property, or feature that helps sort items. So for example, if I'm talking about how many sides something has, that's an attribute of the shape. If I'm talking about its color, its size, is it large, is it small, or its placement, maybe its direction or position, I could sort it based on that characteristic or that attribute, okay? So here we have a bunch of different shapes. What are some different ways that you could sort these shapes? Think of different ones. Don't just pick one and say, oh, okay, I found one way I could sort it. No, let's actually think about it. What are some ways that you could sort these shapes? Okay, well, the obvious one that I see is that you could sort it based on color. Okay, you could have the blue, you could have the yellow, you could have the red. You could take those attributes and sort them based on those, making 3 different groups. You could also then, again, so that was color that I was talking about. If we're talking about sides, I could gather all the triangles. Okay, well, this one has 3 sides. This one has 3 sides. So those would go in the same group. And this has 4 sides. This has 4 sides. So those would go in the same group. And, here we have 1, 2, 3, 4, 5, 6 sides. 6 sides. So that would go in a group with this blue shape over here. Okay, so we can sort things based on its attributes, and that's what we do to classify things. We classify it based on some sort of attribute or characteristic that it has. Okay, another attribute is congruency. Everyone say this word congruent with me. 3, 2, 1. Congruent. Congruent. You're filling in this definition in your notes. Congruent means the same. Everyone say it with me. Repeat after me. Congruent means the same. So for example, congruent sides means that the sides are the same length. Congruent meaning same sides. The sides are the same length. Congruent angles means that the angles are the same measurement or degree. The same measurement or degree, and we'll talk a little bit more about that throughout the lesson, okay? So congruency, if you're not familiar with it, again, it means the same, okay? So what types of attributes can triangles have? What do you notice about these triangles and their side lengths? So when we're looking at triangles, one of their attributes could be their side lengths, the length of the side of the triangle. It's easiest to use the metric system when we're looking at these side lengths. So this is when you're going to pull out that ruler, guys. Okay, so let's look at different ways to classify triangles based on those side lengths. Okay, equilateral. What word do you hear, do you kind of see, even though it's not spelled correctly, what word do you see within the word equilateral? You should see the word equal. Well, okay, I'm talking about its side lengths, and I'm saying the word equal is in there. So if I am having an equilateral triangle, that means all three sides are the same length. All three sides are going to be equal. Okay, we have an isosceles triangle. That's a second way to classify a triangle. One way that I remember that, well, first of all, let's all say that together. Isosceles. 3, 2, 1. Isosceles. One way I remember this is that I have two eyes. Isosceles. At least two sides have the same length. Isosceles. Ha ha ha. We have two eyes. Get it? Oh, okay. So at least two sides have the same length. Scalene. Everyone say scalene with me. 3, 2, 1. Scalene. I'm emphasizing the lean because to me, when I look at a scalene triangle, it looks like it's leaning over. It looks like it's a leaning triangle. So we have equilateral, equal, all three side lengths are equal. Isosceles, eyes, I have two eyes. There are two side lengths that are equal. And then scalene, none of the sides have the same length. Again, it looks like it's leaning to one direction. None of the sides have the same length. Okay, so if you turn to the next page in your notebook, this lesson goes on for quite a few pages because we needed all of these triangles in there. We're going to go through and we're going to classify these triangles based on being equilateral, isosceles, and scalene. In order for us to do that, we need to measure the side lengths. And it's easiest to measure if we use the metric system. So let's go ahead. I'm going to pull up my notebook and I'm going to turn the page. And we're just going to go ahead and measure them together. Why ever not? Can you see the numbers? Beautiful, beautiful numbers on that side. Let's use the metric system, meaning the centimeters, millimeters, just because it's going to be a little bit easier for us. My ruler, again, does not go all the way to the end. It starts here. So I'm going to make sure that that lines up to my corner. And this lines up, and I have mine's about, I'd say 13 and a half. 13 and a half centimeters. Okay, for triangle A, make sure you're looking at the same one that I am. Okay, and then I'm going to line it up, and this also looks like it's 13 and a half. I'm going to label it because I think it's going to be a lot easier for me later on if I label it. And this one looks like 13 and a half. Okay, so based on what we know, we're talking about equilateral, scalene, and isosceles. This one has 13 and a half, 13 and a half, 13 and a half centimeters. So what's one way that we could classify this triangle? We could classify this triangle as an equilateral triangle. Equilateral triangle. Let's keep going. Ooh, isn't measuring fun when you get to use tools and stuff? Ooh, tools. Feels so handy. Okay, so I'm measuring triangle C now, and I see that I have 8.5 centimeters. Again, if you want to write it as a fraction, you can, because you know both ways. Yahoo! Here I see more of a 13.5 centimeters. And this one I see, I'm going to say 20 centimeters. Okay, so I labeled all of my sides. Equilateral, all sides are equal. Scalene, none of the sides are equal. Isosceles, 2 of the sides are equal. So looking at this one, how would you classify this triangle? This triangle is a scalene triangle. Notice how it kind of looks like it's leaning. Ooh, fancy pansies. Okay, let's go ahead and turn because there's more triangles. More triangles. Okay, I'm going to look at triangle F here. Let's look at triangle F. So let's keep measuring, guys. And I'm doing it. I'd love it if you kind of joined in and did it with me, because otherwise it's probably super boring to just watch someone measure triangles. I mean, maybe not, because I'm so cool that it's not that boring. This one's about 19 centimeters. This one is about 11.5 centimeters. And this little guy looks about 11.5 centimeters. Okay, so again, equilateral, all sides equal. Scalene, leaning to one side, none of them are equal. But this one, we have 2 that are equal. Can you remember what that's called? That is called isosceles. Isosceles. Okay, let's keep going. Let's keep it going. Okay, let's keep measuring. We're on triangle B now. Triangle B. So I measured 14 centimeters. That one was pretty nice and clear. This one, again, 14 centimeters. You can kind of tell by looking at it because this is so nicely aligned at the bottom of our page. And then this one is 10 centimeters. Okay, so without me saying it, based on classifying this triangle, how would you classify it? Equilateral, isosceles, or scalene? Say it out loud. Okay, I would classify it as isosceles because 2 of the sides are equal. Okay, let's keep going with our triangles. Triangles. Okay, so let's measure the side lengths of triangle D. This one has 19 centimeters. Side length PQ. Side length PQ is 11 centimeters. Side length OP is 15 centimeters. Okay, so based on our 3 ways of classifying based on side length, how would you classify this triangle? Equilateral, isosceles, or scalene? Shout it out. This would be a scalene triangle. Look at it leaning to one side. All right, triangle E. Let's move it. Let's do, I think that's about close to 15.5 centimeters. This one is close to 15.5 centimeters. And this guy is 21.5 centimeters. So how would you classify this triangle here based on its side lengths? Based on its side lengths. Say it out loud. This one again would be isosceles. 2 isosceles. 2 side lengths were equal for that triangle. Okay, so let's go back to our notes page, guys. Go back to our notes page so that we can write some of this stuff down in it. Okay, so in our notes page, we have the triangle, which has been sketched for you already in yours. So it says sketch the triangle, but that's already done for you in your notes. And then we're going to write down some things about its side lengths, since that's what we're talking about first. And we're working on this column here. Let's go ahead and title it side length in our notes. Okay, so Here was triangle A. How did we classify it based on its side length? We said that it was equilateral. This is the classification we're giving it. And the reason why we classified it that way is because it had 3 congruent or equal sides. Okay, triangle B, again, it's already drawn for you. We classified it as isosceles, and the reason why is because it had 2 congruent or equal sides. Triangle C, we classified it as scalene because it had no congruent or equal sides. Triangle D, we classified it as scalene, again, because it had no congruent or equal sides. Triangle E, we classified it as isosceles because it had 2 congruent or equal sides. And triangle F, we classified it as isosceles because it had 2 congruent, also known as equal sides. If you need to pause the video so that way you can get this all in your notes, that would be a great time to do it right now. Okay, moving on. To show that sides are congruent to each other, we can draw little tick marks. See how on triangle B, we have a mark here and we have a mark here. That shows me that these 2 side lengths are equal. So let's go back on our triangles and let's go ahead and draw those tick marks. Let's go ahead and draw those tick marks. So here we're going to have a tick mark here, here, and here. Because, oops, you're not seeing what I'm doing. Whoops-a-daisies. Okay, so we're drawing a tick mark here, here, and here because all those side lengths are equal. On this triangle, we're not going to draw any tick marks because none of the sides are congruent. On triangle F, we're going to draw a tick mark here and here because those 2 sides are congruent. Triangle B, a tick mark here and here because those 2 sides are congruent. Triangle D, we had no congruent sides, so we're not drawing any tick marks. And triangle E, we're going to draw one here and here to show that those 2 are indeed congruent. Okay? Alrighty. So, why do triangles B, E, and F only have tick marks on 2 of the sides? Because those 2 triangles were isosceles, right? So we don't have a tick mark on the 3rd side because it was not equal to the other 2. Why don't triangles C and D have any tick marks at all? Well, they don't have any tick marks because none of those sides were congruent. Okay? Moving on, this is a little bit of fun for us, okay? So that was classifying based on side lengths. We had equilateral, scalene, and isosceles. Now we have a different way. We're looking at a different attribute of classifying triangles based on their angles. Okay, so let's look at these triangles. Think of things that you notice about the angles. And by angles, what I mean is let's look at triangle B right here in the center. I'm talking about the angle made by this line segment here and this line segment here as they go out from their intersecting vertices. That's the corner that they touch. Okay? So what do you notice about these triangles? Are all those angles the same? Is this angle the same as this angle? And the same as this angle? What are you noticing? Okay, so let's talk about some of the ways that we can classify triangles based on their angles. The first way, and again, this is in your notes, guys, on that front notes page where we have all the things that we need to write down and the little pictures of each triangle there. So go back to, whoopsies, I don't know what I just did. Go back to this page, okay? And we're filling in right here. So you should have the rest of this all filled out and you're filling in right here, okay? So a right triangle has a right or 90-degree angle. Okay, so sometimes you'll hear it as a right angle, sometimes you'll hear it as a 90-degree angle. They mean the exact same thing. Okay, we also have triangles that are obtuse. okay, has an obtuse or greater than 90-degree angle. So what I like to do is I like to put my arms in the air, okay, and I can make a right angle with my arms. Looks like an L, okay. I'm doing it right now in case you can't tell by my breathing. It's like exercise. This is PE minutes, everybody. So I'm making an L with my arms, and then I say obtuse, and it's almost like I'm yawning, and I'm opening up my arms for an obtuse angle. Obtuse, shouting it to the world, okay? Then we have acute angles. An acute angle are all angles that are less than 90 degrees. All angles that are less than 90 degrees are called acute angles, acute angles, which means if all their angles are acute, it's an acute triangle. So let me rewind a little bit. A right triangle has one 90-degree angle. You cannot have more than one 90-degree angle in a triangle. An obtuse triangle has one obtuse angle. You can't have another angle that's obtuse in a triangle, okay? But an acute triangle is a little different, where every single angle in that triangle is less than 90 degrees, okay? So for the right triangle, we made the L with our arms. We said obtuse, like we're shouting it, really big, greater, bigger voices than 90 degrees. And then we have acute angles. And I just say, like I'm talking about a cute little baby. Oh, you're so cute. And I take my fingers and I like pinch them like I'm going to pinch a little baby's cheeks. If you pinch your fingers, you'll notice that you're making an angle that's smaller than that L that you originally had. Okay, so a right triangle will have that L angle, an obtuse triangle will have that big shouting to the world where your arms are wide open, an obtuse angle, and an acute triangle. Oh, cute triangle. Your fingers are going to pinch coming smaller than that L. Okay, kind of like this. Oh, you're so cute. Look at you, you little baby. And then the baby. Wah. Their mouths are open because they're crying because they're babies. Okay. All right. So the fun part. Let's go ahead and classify the triangles based on their angles. First, we need to learn how to use a protractor. So here's a picture of what a protractor looks like. You have access to protractors online. There are many that you could print, and I'm sure they're all good. We've attached some in your little packet as far as a link that you could go to, okay? So let's go ahead and look at how to use a protractor really quickly, because let's be honest, most people don't use protractors on a daily basis. So let's see, do I like that one? Do I like this one? I like that one. Pick about my protractors. Okay, so if I zoom in here, if you notice on this protractor, okay, you'll notice that there's two sets of numbers. There's a set of numbers on the outside, okay, and you'll notice that there's a set of numbers on the inside, but this one starts counting from the left, and this one on the inside starts counting from the right. Which set of numbers do you use? Well, if you notice, they both meet up at 90, okay? So really it depends, guys. It depends on where you're measuring, okay? So for example, if let's see, I'm gonna draw a line here, and I'm going to draw another line here. You do not need to do this. Okay, well, I'm going to use this outside set of numbers if I'm going to start measuring from here and find the other angle, okay? Or the other line, excuse me. I'm going to use the inside numbers if I decide to line up and start my measuring here to find my angle. Okay, so let's review a little bit too. So here I've drawn an angle, all right, and if you notice, there's a little hole right here on my protractor. So that hole is supposed to go over this vertex, corner, intersection of these two line segments. Okay, and you'll also notice that I have this horizontal line going across. That's what I use. So I put that hole there, and then I line this line up with the line I'm measuring from, and I get my measurement. So for example, on this one, let's go ahead and try measuring from the inside, because I'm measuring from this point, right? So it starts at 0 always. I'm not going to start at 180. I start at 0 and I go, and my angle is almost 70 degrees. Not quite, but it's almost 70 degrees, okay? Let's try the other way, where I'm starting on the other side. I'm lining up that I keep saying vertice. I believe I'm right, and I don't want to come off like I'm not. Okay, so I line that up. Remember, I'm not going to start at 100, 180. This doesn't go all the way, but straight lines make 180 degrees. I'm not going to go there. I'm going to start here at 0, 10, 20, you see how that goes? And that again was approximately about 70 degrees. Okay, so that's the angle of this, the measurement of that angle right there. Okay, love protractors. Who doesn't love using tools? Tools make math so fun. Okay, so let's go ahead and classify them based on their angles. So you're going to follow along with me in the notes page, because that's just going to be the most fun. Focus. Okie dokie. So we're looking at triangle A. Triangle A. If you noticed when we did this, one, there's a straight line right here on my protractor, but also that 90 degrees is right here. So hopefully we can easily tell if an angle is 90 degrees, less than 90 degrees, or greater than 90 degrees. So let's go ahead and try this. Let's start with angle Y. See how there's a Y there? So it's called angle Y. So we put the corner in that circle. We line that horizontal line up with that side, and we start measuring. So I'm starting at 0, and I'm going to go, 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 and I see that I'm at a 60. So this one's 60 degrees. Okay, angle Y is 60 degrees. Is that angle acute, obtuse, or a right angle? Well, that's an acute angle right there. Okay. How about here, angle X? I'm going to again put that corner in that circle and line it up. This time I'm going to use this one starting at 0, 10, 20. You got to make sure it's going up correctly. And this one is 60 degrees. Okay, well, I'm going to continue on. Again, that goes in that circle there. We're starting at 0. Oh, that's 180, so I have to use the inner one. And I go, and it lines up at 60 degrees. Well, all of these angles are less than 90 degrees, so this triangle is an acute triangle. A cute triangle. How cute. Okay, let's look at triangle C. Some of you might be able to look at it and you know right away what it is. I don't even need a protractor for this. I can even take a simple sheet of paper that's filled with 90-degree angles, and I see, once I line that up with the bottom of that triangle there, that that angle is greater than that 90 degrees. Greater than that 90 degrees. Let's be formal and actually come up with the actual measurement here. But here I'm lining it up. And I'm going to go to the inside, and that's about approximately, I think I turned my thing. It's approximately 130 degrees. Okay, I can stop right there. Why? Because I have one angle that's greater than 90 degrees. One angle greater than 90 degrees, which means that this is an obtuse angle. Obtuse angle. Okay, let's keep going. Let's measure triangle F. Let's measure triangle F. Again, I'm going to do my little paper test for those of you that didn't take a protractor with you. Notice how that angle is greater than 90 degrees. So what does that tell me about this triangle? It has one angle greater than 90 degrees. It's an obtuse triangle. Obtuse. Let's actually get the measurement there so that way we have it for our records. So again, I'm starting on the inside one, going from 0, it's about 110. So approximately 110 degree angle right there. So this is an obtuse triangle because it has that one obtuse angle. And I probably should put angle J. Angle J is approximately 110 degrees. Okie dokie. So let's look at this triangle. Let's look at this triangle. While I'm doing my little paper corner test, not bigger, it's not bigger, it's not bigger. Were any of those the exact 90 degrees? No. So what can we assume about this triangle? How would you classify it based on its angles? Well, this triangle is an acute triangle. Oh, you're so cute. It's an acute triangle. So this angle W is approximately 70 degrees. I'm going to use my outside numbers. Angle V is approximately 70 degrees. And angle U is approximately 40 degrees. Okay, so all of these were less than the 90 degree angle. So all angles are acute. That means it's an acute triangle. Okay, let's keep going. Triangle D. I'm going to do my little paper test. Ooh, that one looks like it's probably that 90 degrees. So let's take our protractor and let's measure it. Let's measure it. So here we go. Starting at 0. I'm using my inside numbers. Yep. Angle P is equal to 90 degrees. 90 degrees. Well, let's see. We have acute, obtuse, and right triangles. Acute, all angles are less than 90 degrees. Not true. Obtuse, one angle is greater than 90 degrees, but this one's exactly 90 degrees. A right triangle has one 90 degree angle. So if you thought that, you're right. Get it, guys? You're right. Anyways, okay, let's do the test over here. Triangle E. I'm going to do my little paper test. Again, that looks like a right angle to me. I want to double check it because I have this tool. I might as well use it. I'm going to double check it with my protractor. And that's 180. I'm not going to use that one. I'm going to use the inside one. And angle N is equal to 90 degrees. So what type of triangle is this, everybody? Oh my god, you're right. It's a right triangle. You're right. Isn't that joke funny? I don't hear you laughing. Anyways, okay, so let's go ahead and continue to fill in our notes. Okay, so this time we are classifying based on angles. Angles. Two ways that we're classifying today. One was lengths, the second was angles. So we're going back and we're adding information to that front note page. One second. That looks like this. Okay, so you're writing angles here. And then we're writing how we're classifying it and why we're classifying it that way. So triangle A, it was based on its angles, is an acute triangle. All angles are acute, meaning all angles are less than 90 degrees. Triangle B was an acute triangle because all of its angles were acute. All of its angles were less than 90 degrees. Triangle C was an obtuse triangle because one angle is obtuse or greater than 90 degrees. Triangle D is a right triangle because there was one 90-degree angle, one right angle. Triangle E was a right triangle because it had one right or 90-degree angle. And triangle F was an obtuse triangle because there was one angle that was obtuse, which means it's greater than 90 degrees. If you need to pause, go ahead. All right, what do you notice? Well, I see here that I can have a triangle that has one classification. That doesn't mean it meets the other classification. Like, let's look right here. An isosceles triangle, an isosceles triangle. But this one can be classified also as a right triangle based on its angles. This isosceles triangle was classified as an obtuse triangle based on its angles. Okay, same thing for scalene. Just because a triangle has it to where none of the side lengths are the same does not mean that we will classify it the same when we're talking about its angles. Okay, so what symbol do we use to show a right triangle? We already went over symbols to show that side lengths were congruent. Some of you may have seen it before. You'll see these little boxes in the corner of that right triangle. That's what we use to show a right triangle. So let's go ahead and go back. I know I'm going back and forth a lot, but we had our right triangles. Let's see. So we had a right triangle for D. So you would put a little box. You see it like this. Okay, little symbol to show that that's a right angle. And then also for triangle E and angle N, you have a little box to show that that is a right triangle. Okay. Okay, when we're naming triangles, this is what you would see if someone's writing about a triangle. So if this little letter was not on the inside, this would be called triangle XYZ because here we have an X, Y, Z. Those points make up the triangle. Okay, this triangle, which we were calling B, should actually be called triangle UVW. This triangle, which we were calling C, should be called triangle RST. This triangle, which we were calling D, should be called triangle OPQ. And this triangle, which we were calling E, should be called triangle LMN. Notice how we have three letters. Triangles have three sides. Triangles have three angles. Okay, and what we were calling triangle F, it should be triangle IJK. Okay, to show that we are talking about an angle, and we did this already a little bit in our notes, we use this symbol here to represent that word angle, and then we give that letter that's in that inside that angle. So here, this is angle T. What are some attributes that I can use to classify triangles? What are some things that we use to classify triangles today? We used side length and we used angle measurements. Okay? If you were to draw an obtuse triangle, what would that look like? So go ahead and use your paper that you had gotten out earlier or your whiteboard. What might that look like? Well, for me, I like drawing obtuse triangles, something like this. Imagine these are my arms when I'm saying obtuse. Whoops. Okay, so here's an example of an obtuse triangle. Draw an isosceles triangle on your whiteboard or paper. Okay, obtuse, we were classifying it based on its angle. So this angle right here was bigger than 90 degrees. Draw an isosceles triangle. How can I prove to you that that's an isosceles triangle? Well, I can label it showing those two sides congruency. And last one, that one again was based on its side lengths. I have two sides that are equal. And last one, draw a right triangle. Draw a right triangle. This one is classified based on its angle. So again, it's not perfect, but what can I do to show you that that's a right triangle? I can draw that little box in the corner. Okay, thank you guys so much. That was awesome. You're awesome. I know it's a super long lesson, but you hung in there and I'm very proud of you. Go on and classify those triangles. Let's see. Draw lines to identify each triangle according to angle type and side length. This one looks like it would be right. Oh, I think I already did this. Whoops. This one would be right and scalene. Triangle B looks like it would be obtuse and isosceles. And triangle C looks like it would be acute and equilateral. All right, guys, that's it. I'm serious this time. That is it. I'll see you later.